Hello, my name is Erica Betancourt, and I will be presenting chapters 1 and 2 to you. So, really, chapters 1 and 2 were a lot about how to be a math teacher and how to be an effective one. Um, in the beginning of chapter 1, it talks about teaching math in the 21st century and how a lot of students are going to struggle with math because they're faced with the issue of not really understanding why math is what it is, and they don't know why 6 minus 4 equals 2 until you show them. So um, they don't. They're gonna have issues as they get into higher levels of math if they don't understand why math is math. And since society is always changing, that means that teachers are going to need to change the way that they teach. Um, things in 2016 aren't going to be the same as they are in 1976, so teachers aren't going to be teaching the same way. And a lot of that has to do with with a lot of the technological advances that we've been faced with, and jobs that we'll be teaching for that aren't even available yet. So that's going to be a lot of the cause for the change in teaching techniques. So there are 6 principles for school math. The first one is the equity principle, and this is integrated into all the other 5. The equity principle is that all students have an equal opportunity, regardless of their age, their race, their gender, the language they speak, the disabilities they may have, or the family that they come from. Everybody has the same opportunity to learn. The second is the curriculum principle, and this means that curriculum should be surrounded around by big ideas. Students need to see that math grows from one concept to the next, meaning you learn addition and then subtraction, and you can take both of those into, the next step, multiplication and division. And they won't be able to mentally move on until they understand that concept that goes into the next one. The third is the teaching principle. The teacher's attitude about math will set the tone in the classroom. If you display a negative attitude about math, your students will display the same attitude. So if you display a positive attitude, your students are most likely to do the same. Number 4 is the learning principle. Students can learn math. It's just a matter of helping them understand it, regardless of what they think of their ability in the subject. Math today requires more than just computational skills, meaning they don't just need to know how to add 6 and 6. There's more critical thinking involved. This is where the why comes in. Number 5 is the assessment principle. Assessment is an ongoing process all the time in order to monitor the student's success. And one of the big things about this is daily feedback. If you can constantly give your kids feedback about what they might need help on or what they may have already understood, they're going to have a better opportunity to understand what they're doing. And the last one, number 6, is the technology principle. Calculators and computers and everything like that are really essential to learning math. And it's going to help, things like that are going to help students do things that would otherwise be almost impossible. So there are standards. There's 5 content standards, and this is separate from the Common Core standards. Or not separate, but this is what they should be knowing. This is a more general version of it. So the grade levels are broken up from pre-K to 12. They're broken up into 4 different bands or groups. Pre-K through 2nd, 3rd through 5th, 6th through 8th, and 9 to 12. And the 5 content standards are number 1 is numbers and operations, 2 algebra, 3 geometry, 4 measurement, and 5 data analysis and probability. And not all standards are going to be held with equal weight among the grade bands. We can't expect preschoolers to be doing geometry equations. That's not what they're talking about. For example, a preschooler, like I said, won't be using geometry in the sense of completing the equation, but rather learning about shapes, squares and triangles, and maybe how they fit together. So becoming a teacher of mathematics, there's certain characteristics, habits of thought, skills, and dispositions you need to succeed at in order to be a good teacher of math. So the first one is knowledge of mathematics. You must have a full understanding of the content you're teaching to your students. If you don't, they're going to have a harder time understanding what you're teaching. You need to be able to explain to them when they have questions without just repeating yourself louder and slower like most teachers will do. The second is persistence. You need to be able to brush off the feeling of frustration that often comes with math. You'll need to learn strategies that will benefit you and your students, and this kind of characteristic will roll over to your students when it's modeled by you. The 3 is a positive disposition. We talked about this earlier. A positive attitude is the only one your students should see. When they see your positive attitude, they are more likely to succeed in their math journey with you. Now, for us as teachers, a course like this can help reduce the anxiety that may come with teaching math, because we're being handed strategies. We're not having to come up with them ourselves. And things like our toolkit, it's full of things that we can use in our classrooms, and things that'll be really helpful in the future. Number 4 is readiness for change. I said earlier, change comes, and it comes often. As a teacher, you're going to need to be prepared for that, because it's going to come. And it's going to cause some disequilibrium. You're going to be confused sometimes, and you're going to, have to figure out new ways of doing things. And so sometimes things that are unfamiliar may become more familiar, and things that are familiar may become unfamiliar because of the way you're having to change your teaching. The last is lifelong learning. Teachers should never stop learning. We should always be continuing to improve our knowledge and improve the way we teach, and we're going to need to be prepared to be able to do that. So that was chapter 1. I know it was a little text heavy, but it's a lot about, teaching us to be good teachers. So chapter 2 is where we get into the actual teaching of math, and this is about what it means to do mathematics. So before anything else, we have to understand that it's important for students to learn, but we need to know what it is important for them to learn. So by this, I mean they need to understand what they're doing rather than just memorizing what you are doing. So our example here is, what is 3 divided by 1/4? So there has to be more for them to do than just implement a procedure that they've memorized that you've written on the board. And, maybe you can help them apply this to a real life situation. So for example, using pizza, so you have to figure out what is 3 pizzas divided by 1/4. You figure out what they like and figure out how to apply it. And if you can ask your students to start looking for patterns when they see math problem sets, they might have a better understanding. So our example here is 6 plus 7, 5 plus 8, and 4 plus 9. So if you look at this, what pattern do you see? I am seeing a 1 up, 1 down. So if you look at 6 plus 7, you go 1 down in the first number, 1 up in the second number, so on to the last set. But the sums don't change. And these are things that you're going to have to teach your children to understand, and we'll see this a little bit later. You can also explore something a little bit different with older children, like using multiplications and generalizations that can help students learn important relationships. So here you have a set of questions and answers. So even times even equals even, odd times odd equals even, and odd times even equals even. So looking at each of these, you can answer even times even, does it always equal even, sometimes, or never? So these are things you can go over with your students just to kind of get the ball rolling so that they can understand the relationships between numbers. When you're teaching math, you need to be able to use the right kind of vocabulary. Using the correct words in the classroom is going to help your students better understand, and it's going to keep them engaged. So telling them to collaborate with one another, or communicate, or describe the pattern you see, formulate a strategy and figure out what you're going to be able to do. All of these verbs are going to be able to help you engage your students more. So now this is for us as teachers. This is an invitation to do math. So these are just a few activities that you can do in order to gain a little bit of perspective in the science of pattern and order. And these are exercises you can do with your students. They're fairly simple. No more than basic elementary math is required. So let's start with searching for patterns. This activity is called start and jump numbers. So you're going to be given with a number, which is your start, and add a number, which is your jump. So there are 4 sets of numbers here, and if you look at them, you might notice patterns. So for start and jump number 1, your start number is 3, and the next number is 8, so your jump number is 5. 3 plus 8 is 5, 8 plus 5 is 13, 13 plus 5 is 18. So if you look at this, what pattern do you see? Personally, I'm seeing a pattern in the ones place. You see a 3, an 8, a 3, an 8, 3, 8, 3, 8, and it repeats itself. So that might be a pattern that your students see. Start and jump 2, you start with 9, and to get to 12, you're adding 3. 9 plus 3 is 12, plus 3 is 15, plus 3 is 18. When you look at this, what patterns do you see? I don't personally see anything in the ones place, but I see it in the tens place. If you look, you see 111, 222, 333. So you can assume that the next set might be 444, 42, and 42, 45, 48, and then the next set 555. Start and jump number 3, you're starting with 10 and you're adding 4. 10 plus 4 is 14, plus 4 is 18, plus 4 is 2. What patterns do you see with this one? I see one in both the ones and the tens place. So in the tens place, you're seeing 111, 22, 333, 44. You're noticing a pattern of the numbers repeating 3 times and then twice, 3 times and then twice. And then in the ones place, you will notice a pattern of 04826, 04826. So you can assume that you're going to see 50, 54, 56, 58, so on and so forth. For the last set, start and jump 4, you're starting with 15, and you are adding 8. So 15 plus 8 is 23, plus 8 is 31. Are you seeing a pattern here? In the tens place, I see a little bit of a pattern. 1, 2, 3, 3, 4, 5, 6, 7, 7, 8, 9, 10. So your students are going to see maybe different patterns than you see, but there's a new pattern with each set, and you can experiment. Start with 2 and add 2. Start with 7 and add 3, and see what you get each time. The next one is about analyzing a situation. So this is where word problems come in, and most of the time students are going to have trouble with word problems. So here's one that we can help them out with. It's called 2 Machines, 1 Job. So Ron's recycle shop started when he bought a used paper shredding machine. Business was good, so Ron bought a new shredding machine. The old machine could shred a truckload of paper in 4 hours. The new machine could shred the same truckload in only 2 hours. So how long would it take to shred a truckload of paper if Ron runs both machines at the same time? So this is sometimes a little bit difficult. I know it was for me when I was a kid. It still is. It took me a while until I read the answer. So the solution you see below was provided by Cora. So what she did is she broke this down. This whole rectangle, all 3 pieces, represents the 4 hours that it would take the old machine to do the work. So we know that the old machine would take 4 hours to do the whole truckload, where the new machine takes half that time. So, so we're dividing it. So we're showing that the new machine will do half the truckload in 1 hour. The old machine will do half of what the new machine can do. So you're seeing here that it will take 1 hour total for the new machine and the old machine to do 3/4 of the work, leaving just 1/3 of what's left. So 1/3 of an hour is 20 minutes, meaning that it would just take an hour and 20 minutes for both machines to do everything. Sometimes these problems can be really difficult for children, so maybe instead of using a shredding machine, you can use something that they know. How long would it take you to finish building your Lego tower, with you and a friend? You can build it in, 20 minutes. Your friend can build the same thing in 10 minutes. How long would it take you to build it together? So relating things to them is going to be a big part of what you're doing. This next one is about generalizing relationships. So this is called 1 up, 1 down. So we're going to start with addition. When you add 7 and 7, you get 14. But when you make the first number 1 more and the second number 1 less, you'll still get the same answer. So 7 plus 7 equals 14, but so does 8 plus 6. And so how do you relate this to students? One of the strategies I personally came up with was if you have 7 apples on the left side and 7 apples on the right side, you still have 14. But if you take an apple from one of the sides and add it to the other, your sides end up having different numbers, but your total number doesn't change. So this is something, if you have a smaller manipulative, like maybe the counters you have in your toolkit, maybe you can give each student, 14, and with them you can show them, just because you're moving one to another pile doesn't mean the total number changes, just the numbers in each pile change. And the same thing works for multiple numbers, 5 plus 5. 5 plus 5 is 10, 6 plus 4 is also 10. So we're looking at this and just think about, does maybe this work for any other doubles? 6 plus 6 is 12. What is 7 plus 5? Is 7 plus 5 also 12? It is. So you can show them these relationships with different numbers and showing them that the total number doesn't change even if your first 2 numbers do. For older children, you can maybe look at, does 1 up, 1 down work with multiplication? So the example we see here is 7 times 7 equals 49. But if you move up to 8, move 7 up to 8 and the other 7 down to 6, it equals 48. So this might not necessarily work with multiplication since you're not using, since you're not just adding things together. But that might be a relationship that you can show your students in showing them that this particular generalization doesn't always work with across all parts of math, subtraction, addition, and multiplication, division. The last one we're going to do is called experimenting and explaining, and this one's called the best chance of purple. So for this one, our problem is Samuel, Susan, and Sandu are playing a game. The first one is spin purple wins. Purple means that 1 spin lands on red and 1 spin lands on blue. Each person chooses to spin each spinner once or spin one of the spinners twice. Samuel chooses to spin spinner A twice, Susan chooses to spin spinner B twice, and Sandu chooses to spin each spinner once. So we're looking at who has the best chance of spinning purple. So you'll see the spinners that are provided for the problem. Spinner A is divided into equal quarters, red, yellow, green, and blue, where spinner B is divided into, if you look at it, sixths. So a sixth of it is red, a sixth of it is yellow, a sixth of it is green, and 3/6 is blue, meaning half of it is blue and the other half is divided into thirds of red, yellow, and green. So if you look at this and take into account which method each person chose, who has the best chance of spinning purple? So on the right side, you'll see a diagram of the chances that each color has to be spun on the spinner. So spinner A is divided into equal quarters. So you'll see the bar graph is also divided into equal quarters of red, blue, green, and yellow. But spinner B is divided a little bit differently. Like we said, it's divided into, if you look at it, into sixths. So you'll see 6 bars. If there were lines on the spinner, you would see that there would be 3 blue triangles. So you'll see 3 blue bars and then 1 of each yellow, green, and red. So you'll notice that the probability of spinning blue on spinner B is more than if you were to spin blue on spinner A. So just kind of talk about this with your students and ask them, if I were to spin this, what are the chances that I would get blue? Would it be more than getting the other colors or equal or less? So those are things that they can come up with without you having to give them the answer. So the next thing we're going to talk about is being mathematically proficient, and this goes for students and for teachers. This means that there's multiple things a student should be able to do concerning a concept of math. So we're going to take the example of the fraction 6/8. So what is it important to know, and what should the student know, and what should they probably know or might be able to do? They should be able to read the fraction. They should be able to say it's 6/8 or 6/8. They should be able to identify the 6 and the 8 as the numerator and the denominator respectively, meaning the numerator is 6, the denominator is 8, top and bottom. They should recognize that it's equivalent to 3/4, or 3/4. And you should be able to show them that, just like with the spinners, we didn't necessarily see the black lines dividing the blue, but we know that there was 3 of them. So you should be able to show that they should recognize that that's essentially the same. They should be able to say that it's more than half and recognize relevant size. They should be able to see that 3/4 is just a little bit more than half, by maybe drawing a pie chart or showing them, with counters or whatever you have. The next one, you can use a pie chart, a blank one. Draw a region that is shaded in a way to show 6/8. So a pie chart that's divided into 8s and 6 of them are shaded, showing 6/8. They should be able to find 6/8 on a number line. So if you can relate this to 1, which would be 8/8 being the whole, is 6/8 less or more than 1? They should be able to do that. And they should be able to illustrate 6/8 out of a set of 48 pennies or counters. And you could help them do that, and they should be able to show that fraction with those. So there's lots of other things that we can do. I know the presentation's over. We're just going to talk about a couple of other things. There are a lot of strategies that teachers can use in order to successfully teach their students. So there's not necessarily one right or wrong way to do it. It's whatever works for each teacher. But you're gonna face struggles with different students, students who may or may not speak English, students who may have a learning disability, and this is where those principles come in. You know, um, those the 6 principles of school mathematics, the equity principle. Every student has the same opportunity to learn, and so you should, as a teacher, be able to adapt to that and teach each student um, differently and the same in the same way. Um, Making sure that your students know that you care about them is a huge part of being a teacher. Making sure that you understand their struggle and that they might struggle is also a big part of it. We all understand what it was like to be a student in a math class at one point, and we need to be able to take all these strategies that we're learning and apply them in a way that will make the students have a positive attitude about mathematics and feel as if they are actually learning rather than struggling with what they're trying to understand. So, as teachers, we just need to make sure that we're on top of these things, that we're constantly researching new techniques and how to keep children engaged and making sure that the strategies that we are using actually do work with our students, because if they're not, we need to be able to change that up. So, just keep that in mind as you're going through this course. This is what this course is about. The course is about teaching you what it is to teach mathematics and what it is to help your students understand it. Thank you very much.